When running a 120 volts alternating current circuit with a 6 American wire gauge hot and neutral wire and polyvinyl chloride conduit through a trench, alongside a 6 American wire gauge copper ground wire in the trench but not inside the conduit, and with ground rods installed at both ends of the trench, the question arises whether a separate 10 American wire gauge ground wire is necessary inside the conduit. Based on standard electrical practices in the National Electrical Code, it is generally not necessary to run a separate 10 American wire gauge ground wire inside the conduit in this specific scenario. The primary reason is that the 6 American wire gauge copper ground wire running outside the conduit, in conjunction with the ground rods at both ends of the trench, provides a sufficient grounding path for the electrical circuit. The ground rods establish a low resistance connection to the earth, and the 6 American wire gauge wire ensures a robust connection between the conduit and the grounding system. The National Electrical Code, or NEC, which serves as the benchmark for safe electrical installations in many regions, typically does not require an additional ground wire inside the conduit when a separate grounding electrode conductor is installed outside the conduit. In this context, the 6 American wire gauge copper ground wire effectively acts as the grounding electrode conductor. To elaborate further, let's consider the fundamental principles of electrical grounding. The primary purpose of a grounding system is to provide a low impedance path for fault current to return to the source, which facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses. This rapid operation is crucial for preventing electrical shock hazards and minimizing the risk of fire. In a typical electrical system, the grounding system consists of several interconnected components, including the grounding electrode conductor, and the equipment grounding conductor. The grounding electrode, which is often a ground rod, ground plate, or underground metallic water pipe, establishes a direct connection to the earth. The grounding electrode conductor connects the grounding electrode to the electrical system's grounded conductor, typically the neutral bus in the service panel. The equipment grounding conductor, which may be a wire or metallic conduit, provides a path for fault current to flow from the equipment back to the source. Now let's analyze the specific scenario in question. The 6 American wire gauge copper ground wire running outside the conduit serves as the grounding electrode conductor, connecting the ground rods to the electrical system's grounding point. The ground rods provide a low resistance connection to the earth, ensuring that fault current can flow safely back to the source. The conduit itself, if made of metal, can also serve as an equipment grounding conductor, providing an additional path for fault current to flow. However, even if the conduit is made of non-conductive material such as polyvinyl chloride, the 6 American wire gauge copper ground wire provides a sufficient grounding path. According to the National Electrical Code, specifically Section 250.4, grounding shall be installed in a manner that creates a lower impedance circuit facilitating the operation of overcurrent devices. The earth shall not be considered as an effective ground fault current path. In the described scenario, the 6 American wire gauge copper wire in the trench acts as an effective ground fault current path when supplemented by ground rods at both ends of the trench. The NEC Section 250.130 also covers the use of grounding electrode conductors. Therefore, it is essential to ensure that all connections are properly made and that the grounding system is installed in accordance with all applicable codes and regulations. Furthermore, it is advisable to consult with a qualified electrician or electrical engineer to ensure that the grounding system is properly designed and installed for the specific application. The size of the grounding electrode conductor is determined by NEC Table 250.66, grounding electrode conductor for alternating current systems. The size of the grounding electrode conductor is based on the size of the ungrounded conductors. In this case, the 6 American wire gauge hot and neutral conductors would require a certain size grounding electrode conductor based on the table. The 6 American wire gauge copper ground wire is likely adequate for this purpose, but verification with the table is important. The equipment grounding conductor, installed in the conduit, is sized according to NEC Table 250.122, minimum size equipment grounding conductors for grounding raceway and equipment. Again, the size depends on the rating of the overcurrent protective device. However, because a supplemental grounding electrode conductor is installed, this requirement is mitigated. It is important to consider the impedance of the grounding path. Impedance is the total opposition to current flow in an alternating current circuit, and it includes both resistance and reactance. A low impedance grounding path is essential for ensuring that fault current can flow quickly and easily back to the source. The length of the grounding conductors is also a factor. Longer conductors have higher impedance, so it is important to keep the grounding conductors as short and straight as possible. The type of connections used is also important. All connections must be clean, tight, and corrosion resistant. Approved connectors should always be used, and connections should be made in accordance with the manufacturer's instructions. Regular inspection and maintenance of the grounding system is also important. Ground rods should be checked periodically to ensure that they are still properly driven into the ground and that the connections are still tight and corrosion resistant. Grounding conductors should also be inspected for damage or corrosion. Any damaged or corroded component should be replaced immediately. In summary, while local codes and specific installation requirements can vary, the setup described, with a 6 American wire gauge copper ground wire running outside the conduit and supplemented by ground rods at both ends of the trench, generally provides an adequate grounding path. Therefore, a separate 10 American wire gauge ground wire inside the conduit may not be necessary, provided all connections are properly made and the system complies with all applicable codes and standards. However, consulting with a qualified electrician is always recommended to ensure compliance with local regulations and to verify the specific requirements of the installation. It is crucial to emphasize the importance of adhering to all applicable electrical codes and regulations. Electrical codes are designed to ensure the safety of electrical installations and to protect people and property from electrical hazards. Failure to comply with electrical codes can result in serious injury, death, or property damage. Therefore, it is essential to consult with a qualified electrician or electrical engineer to ensure that all electrical work is performed in accordance with all applicable codes and regulations. Furthermore, it is important to understand that electrical codes can vary from one jurisdiction to another. Therefore, it is essential to consult with the local electrical inspector to determine the specific requirements for your area. The National Electrical Code is a comprehensive set of standards for electrical installations, but it is not a law. However, many jurisdictions adopt the NEC as their electrical code, either in whole or in part. The NEC is updated every 3 years, so it is important to ensure that you are using the latest version of the code. In addition to the NEC, there may be other applicable codes and standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or all. It is important to be familiar with all applicable codes and standards before performing any electrical work. Finally, it is important to remember that electrical work can be dangerous. If you are not qualified to perform electrical work, you should hire a qualified electrician. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Attempting to perform electrical work without the proper training and experience can be extremely dangerous and can result in serious injury or death. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work.